Hello, this is Jennifer Martinez. In this video, I'm going to compute the derivative algebraically, and I'm going to use the definition of the derivative. So let's do this example. Find the derivative of f of x equals 1 over x at the point x equals 2. So let's first write down what the definition of the derivative is. So we know f prime of a is equal to the limit as h goes to 0 of f of a plus h minus f of a over h from the last video. And we're going to have here, in this case, a is going to be 2. So f prime of 2 is what we want to look for. And that is going to be, still you're going to have h is going to go to 0. We're going to get 2 plus h, f of 2 all over h. So we know, I'm going to write the limit here, that f of 2 plus h is 1 over 2 plus h, since this is f of x right there. And then we're going to subtract there f of 2, which is 1/2. I'm going to still divide that by h. So I have a double fraction here. So I'm going to multiply numerator and denominator by the LCD of that double fraction. To get rid of that complex fraction. And so that is going to be equal to, I'm still going to have the limit as h goes to 0. But I'm going to multiply this, and the 2 plus h's cancel, and I'll just have a 2. And then we did this on an activity last week. Divided by 2, we get a parentheses 2 plus h all over, I'm going to have a 2h here, 2 plus h. You have to be careful not to cancel anything yet. I'm going to get rid of the parentheses there. And now I can cancel those 2's. So I end up with is just a negative h over 2h parentheses 2 plus h. I'm not going to multiply out the bottom. And no, before we plug in, because 0 over 0 doesn't make sense, we know that probably means there's a hole. So I'm going to cancel out those h's and get negative 1 over 2 plus h. Again, I'm just canceling those out there. So we get a negative 1 and a 2 on the bottom. You can multiply this out if you want now, or you could just plug in, because now there's no problem point, there's no hole. That is a continuous function at x equals 0. So that is going to be 2 plus 0, or just negative 1/4. That is the answer. The derivative of 2 is negative 1/4. To get a visual of this, we know that we can graph f of x equals 1 over x and look at the point x equals 2. I have it right here. So here's the graph of f of x equaling 1 over x. Make this smaller so we can see it up there. There it is. So we can see the whole thing. And here's the point 2. And at that point, you can see that the slope is negative 1/4. If you really wanted to see that, you can go down 1 and over 4 and extend that line. So you can see I went down 1. This is about right there, about halfway through, and then over 1, 2, 3, 4. It is a point on the line. And now, if you're asked to find the equation of the tangent line, you can do it because you have that slope. That slope was negative 1/4. So you can now take your equation of your line. You know your point, f of 2, your x1, y1, is 1/2, since you have the function there, or x1, y1, and you know your slope is negative 1/4 that you found up here. So now if you just plug that in, you get y minus y1, which is 1/2, your slope, x minus 2. There it is. Let's multiply that out. So you get negative 1/4 x plus 2/4, or 1/2, and then I can add a 1/2 to both sides. And our answer is going to be y equals negative 1/4 x plus 1. That's the equation of that line. So it must pass through 1. I believe it. Hope that helps.